Okay, so this is my Friday Fun Day presentation. My name is Brianna Brown, and this presentation is going to be over perception of color underwater. It's a natural phenomenon that happens all around the world. Anywhere you go, it's not dependent on what type of water you're looking at. So, um, water absorbs light, and it absorbs light differently depending on how deep the meters of water you're in. So the deeper the water, the more dull colors become. The color itself does not change. So if you took something that was red that changed into perception of blue out of water, it would still be red. It's the water and the way that the light cuts through it that changes the perception of color. So the longer the wavelengths a color has, the less power it has underwater, meaning that different colors disappear at different depths. Went over this. Red has the longest wavelength. It's also the slowest, which means that it becomes dull first. And so a good way to remember this is remembering the rainbow: red, orange, yellow, blue, indigo, violet. That's kind of the ranking of power as far as wavelengths go and how strong they are. So red being slower and less strong is gonna become dull faster. Something that's orange wouldn't be as fast. So on and so forth. This is why when you go down deep underwater, a lot of the colors on the spectrum disappear and most everything looks blue or green. So the brain does try to compensate for the lack of color that we can perceive underwater, but this only goes to a certain extent. Our memories of what colors are supposed to look like kind of tricks our brain into thinking that it looks the same, but it really doesn't. Kind of just like when you see something, it looks like the shape of a dog in the clouds. It's not actually a dog, but because the form looks similar, your brain transfers that memory onto the object that you're looking at. It's the same concept with colors. But cameras do not compensate the same way that the brain does. This happens a lot. I mean, cameras really don't take good pictures of nature. You know, you try to take a picture of the moon and the illumination just doesn't look the same. Kind of similar with underwater and colors. If you try to take a picture of something really, really deep underwater, it's going to look super dull and the colors are not going to look that good. So also another variable that changes it is the conditions of weather. So if you have a day where it's really windy and rainy, the top of the water that the light shoots through is going to be more rough and the light's not going to be able to be as effectively, it's not going to cut through the water as effectively as it would in other conditions. So the best day to take pictures underwater or to see the closest perception of what colors look like on land is a day where it's calm, no rain, no wind, and sunny, when the sun is up at its highest point in the sky. So this slide shows an example of pretty much everything I just talked about. The first picture, it shows you that it's at a depth of 155 feet. And the first one is just below the surface. You can see it has black, brown, purple, blue, a couple different shades of green, yellow, orange, pink, red. And then when you go down farther, I mean, you can see the first four, even one of the green ones, they look blue. And this is why. This is exactly what I was talking about. They look dull. And you can see the red one actually looks dark. It looks black. Like I said earlier, red is definitely the most affected by this phenomenon. And the second picture I have here is kind of like a visual representation of however many meters and feet you go down, and the like the spectrum of color and light and the way that it gradients down. The top one is the full light spectrum, and you can see at 3 feet the red part of the spectrum of light has already lessened, and then at 16 feet the red is almost gone, and you can still see the yellow and orange, and then 30 feet you're mostly seeing green, yellow, blue, purple, and then at 66 feet you can't see any of those colors. It's mostly green and blue. And then obviously the deeper you go, it's very dark. It's hard to see any color at all. So yeah, where do the colors go? They're not actually going anywhere. It's the light and the way that the water absorbs it. So the human eye can only see a small portion of what is found on the electromagnetic spectrum. What is visible light spectrum? So the visible light spectrum is a small portion of the electromagnetic spectrum. What colors we can see and perceive through our eyes is actually a small spectrum of what colors actually exist and that can be seen. So the visible light spectrum is composed of all the colors of the rainbow. Each one has a different wavelength. We've talked about this. The length of each wavelength is dependent on the amount of radiation it possesses. The radiation is the energy of the light. So how does this apply to the spectrum of color? The longer the wavelength, the quicker the color is absorbed under the water. Like I said earlier, red has a longer wavelength. It's slower, which means it's going to be absorbed faster and you're not going to be able to see it at deeper depths. But blue has a faster, shorter wavelength, which means that it can cut through water and it can be seen at deeper depths. So this slide shows what light is affected by. It's not only affected by the water. Well, the water is like the baseline, but depth, subject distance, weather, and surface conditions are all variables that change the way that color is perceived. The human eyes can compensate for loss of light, raise radiation underwater through the use of white lights on strobes. So what this is meaning is people who do scuba dive and they experience this natural phenomenon a lot, they use strobe lights of white light to illuminate their subjects. And this white light is kind of like, it's small in comparison, but it's trying to like minimalize and use the same type of radiation the sun does to illuminate all the colors on the visible light spectrum. Let's see. So the relevance of light absorption in marine life. This is really interesting because animals have adapted their own bodies, the colors on their bodies, to keep them alive. Red appears in shallower water and blue doesn't. So this means, blue does appear on shallower water, but red turns into blue at a deeper space in the ocean. So that's why a lot of animals are red, because when they go down deep into the water, they blend in, because most of the colors down there are blue and green. And if they can camouflage into that environment and use the light absorption in water to their benefit, they're going to be less subject to being preyed upon by predators. So what happens if an animal needs to go to a shallower depth to find food or get more oxygen from the water, because there's more oxygen in shallower water? So I thought this was really interesting. Fish have bright underbellies, which allow them to camouflage with the light shining down into the water. So it's not only that they use the natural phenomenon of light absorption to their benefit to camouflage, deep underwater, but also from a higher depth too. Um, a lot of animals do this even when it's not in the ocean, but this is the way that marine life has used this natural phenomenon to their benefit. So in this slide, you can see what I'm talking about. Fish who exist and thrive at a higher depth, they don't have as much of a need to be red. They can be blue because their camouflage is already there. But fish that are at a deeper depth, where it's really, really dark, they have adapted to become red because red is going to transfer into a really, really like dark gray color, which is interesting. I showed that earlier on the slide with the tubes. I talked about the red and how it almost looked like a really, really dark gray. That's an example of how they camouflage. And this picture right here with the angelfish, this fish exists at a very, very deep depth in the ocean. And you think, oh my gosh, it's really bright, it's going to be targeted more. But this is not true at all. We are under the impression that these animals, when you're underwater, they always look like this. The way that we have found this picture and created this picture is through a white light strobe light. So that's why you can see its color. But naturally in the environment, this fish would not even be visible to the human eye. Okay, so here are my citations, some articles and websites that I use to find pictures, as well as collect all the information that I needed for this project. I hope that you guys find this interesting, and maybe go find some YouTube videos or do some more research about this natural phenomenon, or if you've never heard about it yet, now you know. Now you have some fun facts to tell people next time you go to Florida or you're in the ocean. Anyways, thank you.